Today I'm gonna be messing around with the UI. It's been a while since I've last had a stream, but I've had the chance to do some minor work on different stuff. So right now this is how everything has evolved since last time. Now you can add a list box of things that gets their own scroll bar depending on the size of the contents. Yeah, there are some different issues with the kind of like the whole rendering process, kind of like not really respecting or acknowledging the clipping itself, so everything kind of like flows outside the borders of the contexts themselves slash the primary window for each context. So yeah, I guess I will be looking into that. Also, this could be changed into something like a item of sorts where we can pass out the selected ID. Yeah. But this gives us the option of using nested scrollable windows. I guess this doesn't look very good when the scroll bar here collapses. But yeah, I think I'll do some. Whoops, let me just set up the YouTube chat here. I haven't. Since everyone wanted the fast speed chats, all I have to do some resetting between each stream. Let's see. There we go. Okay. So yeah, I'll do some debugging here. Let me tell the system that it should tell us the rect. Let's see, do I have some sort of debugging function that I used? Yeah, I used this one earlier. So yeah, I'm thinking that it happens inside this function with the overlap test here. So let's debug that. Bounding volume. Let's see, and we simply also want to tell the result of our function. Oops. And also we want clip rect, which is our window clip rect here. Okay. So the idea is that we check if the smallest rect here let's see that our smallest rect is actually inside our other rect. Which can only be the case if let's see, where did we call it? We called it inside our application, yeah. So we call this let's see, is this actually correct or not? I want to see if this is correct. Um, so yeah, we want to yeah, maybe we want to flip this actually. Yeah, maybe we want to flip this. Let's see. This item hovered, cursor pressed, text size. So I mean, what if we flip this? Will the clipping be better? Let's see. It doesn't matter too much, I think. Yeah, the constant spamming of the text here really tanks the FPS. Let's see. Our clipping doesn't get any better, it seems. But doesn't this supposed to? Isn't this supposed to? Well, does it work either way? Let's see. Hmm. Are if the minimum is lower than the maximum on the bigger one, and the maximum is bigger than the minimum, it must be inside, right? But are we doing it in the wrong order? We might. Hmm. Yeah. Let's see. Let's compare. Let's see. Let's do it for the buttons here. Uh, uh, let's see. Current window. Instead, we just want window. Should always call it window, but let's see. Print and label. And we print the label here. Okay, then we will know which button we're processing here. I especially want the one that is called test button, yeah. Because I don't think it should show so high up. Test button here. Bounding volume. Well, let's copy these values. And compare them. So our clip rect starts at this x, this is the minimum, this is the maximum. And the bounding volume here, let's see in our overlap test. Did we actually get test button is overlapping? So that evaluates true. Okay. So let's walk through the test here. So the way this should work is that our smallest, okay, right now we pass in the bounding volume as the smallest. So this minimum x, right here, this minimum x should be smaller than this maximum x, which it is, this minimum y should be smaller than this maximum y, which it is, then our, at least from this logic here, let's see, our smallest maximum x, which is 99, should be bigger than the minimum x, which is also true. Well, I'm starting to think that this is not the right way to go. Anyway, what if we flip them? So let's say that this is the smallest one, quote unquote. So the minimum x is supposed to be lower than the maximum x here, which is true. The maximum x here is supposed to be bigger than the minimum x here, which is true. The minimum y here is supposed to be smaller than the maximum y, which is barely true. Yeah, I'm not sure this test is correct actually. I'm not sure this test is correct. Maybe we should do something else instead. Let's see. Maybe if we just return this. Well, it shouldn't make any difference, but let's try doing it. Well, it's just pigeon superstition. But yeah, as you can see, it's not really well, let's see. Maybe we calculate too big of an bounding box. Let me see. But the spacing itself seems okay. Hmm. Hmm. Okay. I don't think this way of checking for the overlaps really yeah, really does what it's supposed to, because as you can see here, everything kind of like overflows. Well, if we change the clip rect itself to something even smaller. Yeah, we could change it. But but the comparison is probably the problem. Let's see. So test button 1 here. I mean, the bounding volume, and once this value here gets uh, lower than this, well, so the difference is, do we want a contain check or a overlap check? Because this just checks if they ever overlap on some axis. But for instance, if we did something like, well, we could just compare the minimum and maximum distances, and if all of these smaller ones are inside, it would contain direct. I guess you could manipulate the clipping rect itself. Also, well, yeah, if we do something like this equals minus maybe 20, of course, semicolon here. we would get some, as you can see now, the thing here doesn't overflow anymore. Everything looks better, and the same could be done for the minimum y here. Minimum y plus equals maybe 15 here. Let's do this instead. And let's stop dumping the information here to the console, since it's slowing us so much down. Let's remove this as well. I need to remember the semicolons, of course. Okay, the clipping gets better. But we end up risking having parts of the window where we kind of like don't draw anything and get a weird border-like effect. So yeah, we have to handle the clipping itself if we want to do that. Well, it's a fix for something that does look pretty bad when whenever we do that. Maybe when we add some styling, maybe a header or something. We don't care for the whole scroll thing anyway, and we will probably be drawing the header of the window itself beforehand, and then everything will just seem to like slide under it. So, since it will stay in place. But yeah, and this of course needs to be something that is more how could you call it, selectable. Right now I just fill in let's disable these, we don't need them right now. Yeah, and I should clean up some of this code as well, but yeah. As you can see here, inside my list box here, I simply add some buttons. We do not add any logic to them right now, so they are drawable, hoverable, whatever, but yeah. We should also add some custom width for this. Maybe I'll just do that here. Well, we could just add it in the, well, I don't know. This is the text size. Frame size. Maybe we want something like plus 25, potentially, depending on how big of a text we get. That gives us more space for this thing here. Well, we can play around with settings like that. It's fairly easy to change. But yeah, I should definitely do something else than this. We should have some sort of parameter up here that we can feed a reference to a value into, and expect the list box to kind of like remember the selected state. So let's try working out how we do that. Because, yeah, the outline here, not here. What is that actually? Oh, it was when I tested the asynchronous UI thread. We can always do that. We have a lot of unconditional UI calls here. As you can see, we probably don't need to. That's some debugging. Okay, so we have kind of done that. We haven't done. This was something that I needed a fix. We will change this. Change into a allocator system with handles to retrieve pointers. Yep. We will do some custom allocations for the UI eventually, but yeah. When we add a list box, we should add some sort of item type inside the recording of each, or rather the child window inside the list box. That this is basically what creates a scrollable area inside our primary window. It's a child to the original window, which is why it's called registered record child window. Let's see. So let me see. I need some stuff here on the stream. Okay. Let's see if we are to create that. We don't care about, or rather would rather not have a public function for that, because it doesn't make sense that we create these things. Yeah, we don't need the ability to create these things wherever we want. We just want the list box to be generated. Let's see, string. I have to test out whether these, or check out if these strings here are slow. They shouldn't be const because we might modify them. There we go. Something along the lines of this. Maybe we want a item value, maybe. Yeah, let's see. Let's see what we would like. Let's create this function here. We will grab our window, which will be our child window, actually, in this situation. Current window, window, there we go. We should probably get a handle, UN64 handle, which will be, what do we call that function? Create handle, compute handle. Window, ID, item ID. Well, maybe we want that to be set sometime. For now, we will just set it to 0, and then we will add a const unsigned int cast to our label C string. Evic position is equal to our window frame data cursor position here. And we would like to not add item, but let's see, draw rect. No, that's not it. That's not the one I'm thinking about. Draw cursor. Recalculate draw cursor. Let's see, AVIC2 size, which could be our size, but right now we could simply just make it 15 pixels wide and 25 pixels high. And then we want to recalculate the draw cursor of the window, p context with our item size here needs to be fixed. Computed slash fixed. And well, we need some button stuff as well. It's basically like a button, right? It's basically like a button of sorts. Yeah, so the idea is that we create a label. We could also draw the selected one as a different color. So imagine one of these buttons here being a different color if the object was selected here. Um, uh, yeah, so that's the option. So simply let's create a flag, const bool selected. We won't be changing it. But yeah, mostly it will behave like a button. So in our button function here, we first check, is it even well, we of course add the redrawing, then we calculate the bounding volume of it, and then we check if the item is clipped or not by the window itself by using the handle. We check if the active handle is the one that we're being passed inside this function, and we tell the system to keep that handle alive because this item, even though it's not drawable, is actually being updated, at least internally, in terms of being used for something. Uh, yeah, and as you can see here, we do some calculations. Well, yeah, mostly we will just copy this. Yeah, so that should handle our button stuff. So whenever we click something, it should change the color. We could do something like a scroll to function that whenever a item is selected, that we update the scroll state of the window itself. That would be pretty easy to do. Yeah, yeah, that's probably what I'll do. I'm pretty tired right now, so I've been at work. So we'll see. Well, maybe I should just do it. Albeit a bit slowly. Okay, I'll do it. So let's do the adjustments so that the list box is more or less complete. Yeah, there are some definite improvements to the UI that we would like to make. But right now it's close to functional. Thank you very much, man. Welcome to the stream. So we should probably. Thank you very much. How kind of you. Hopefully I'll be done with the UI stuff and can start building a real level editor here in the coming weekend. I at least hope so. It's been a while doing this UI rework. But that's what you get when you implement a janky UI. You need to redo it. Okay, so the list box item here does the recalculation. Then we want a bounding volume here. Bounding volume. Which we will calculate from our will be our position, and our maximum will be our let's see, do I have I think I have added some helper functions. Add oh, that's the vectors. Oh well, we want that as well. So let's see, add vec here, position and size. This should be our bounding volume. Then we want to ask the system, could we add the item inside our context here, and with our bounding volume here, and then our handle. If not, we will return false here. If we succeed, the item got added, as we can see here inside our button function. And then we can start checking if we are hovering slash clicking slash if it's the selected item. So we simply do that. Now we have some information here. Let's see, is it pressed? Yeah, we want to return that. Hovering is a check that we do. We do not do a held check here. We don't care if someone grabs a item on the list and tries to drag it around. We really don't care. So we calculate some colors here. And we, whoops, that's the button. Where did our list box go? Let's close some of this. That's our list box here. Our list box item. Well, yeah. Okay. Whoops. And the bounding volume is just. Well, right now we won't do any string parsing, I think. Edited string. Well, let's wait a sec with this. Okay. Hovering. And we simply in this function here, we can ask if it's hovering. If it is hovering, well, we don't mind this, but otherwise we want to check if it's selected. If it is, we want a different color. And this one, let's see, right now we do blue. Let's do green if it's selected, just to keep things simple here. Otherwise we set it to blue. Right now we don't render any text. Okay. I think that was most of the updating that we need to do. Let's just keep that hovering. Well, I should really just change this. Let's rewrite it wherever needed. Let's see if out hovering, it should be dereferenced and set to this value. Yeah. Okay. That means that we don't need to specify this. Hello, buddy. How you doing? Is item pressed out hovering? Oh, wait a minute. I haven't updated the actual function declaration here. I'm doing all right. I'm doing all right. Doing a bit of streaming here before I have to end the day. Let's see. Okay, so our function here is pressed. There we go. Let's pass it by reference then. Hovering. Well, now we don't need this. Let's do only selected. Well, how? Oh, I actually wanted a hovering here. It was just maybe somewhere else. I don't want that. Hello, welcome. So if it's selected, we do one color. If not, we do something else. So if we add a list box here, we should be able to specify a unsigned int selected item. Thank you very much, man. Thank you very much, and thanks for all your support throughout the channel history. Let's see, we want a const unsigned int. Number of items. We need to edit this because it will have to change eventually. Let's see, do something like this. Okay. And of course, inside our application here, we want to specify unsigned int selected equals 0. Yeah, I watched it. I also wrote you a message. It looks pretty nice. It's some good work you've done. Let's see. There we go. Are we done updating? Yeah. So now we want to draw this dynamically here, so that instead of some pre-specified buttons, that we actually do a list of stuff. We will do a rather simple implementation first, so we will have a number of items. And for number of items, we will add a list box item. Let's do some temporary stuff here. String name, and we will set that to item number, and then we will append the to string. Let's see, it's inside the standard library. Yeah, to string our I value here. We will append that. So we will pass in our context. We will pass in a std move on our string here, which will turn it into a temporary. And then selected item. Now we need a bool here. Bool is selected. I equals selected item here. Equals, there we go. So we pass in the bool here, and these sizes just auto-generated for now. Okay, let's try this. And as you can see, the first one is green because it's selected. The rest ones are blue. So the last thing we need to do is to make a check here, because if this one is pressed, we want to set our selected item to our index value. But this means that we in our application can't use this temporary anymore. We will create a temporary value that persists between frames, because we store it in our application here. Tester value 0. Okay. So tester value 0, and we will It's been all right. It's been all right. I've been at work, and yeah, could be better, could be worse. Okay, let's see. Okay, right now we do not update anything, even though I'm clicking. Tester value. Okay. Let's see if we actually, excuse me. Oh, the handle should be all right. Let's see if we actually pressed something. Pressed I. So we will check our console here. Press 2, 3, 4. So it does register, but it kind of like forgets between frames which value is set. Let's see. Maybe I copy. Oh yeah, I copy the value. That's why. We're copying, not referencing. That's why it's not working. Silly me. There we go. So now, okay, we're still not updating our value yet. For some reason, let's see. Oh, I reset it every frame. Whoopsie-doo. That's why. That's probably even now. That's not the problem to begin with. We also need to reference it. So now you can see that we are able to select different items here. Let's increase the size so that we can get our scroll bar back on our list box here and see how it behaves when we scroll. So let's click that. I really need to fix the yeah. Okay. We could add some auto scroll for this function, meaning that whenever something is selected, we try to focus on that. Not that it matters too much. I don't think I'll be bothered too much. Okay, so let's add some text. And we will simply just add some text here. Let's just do the full label here. We don't need to restrict it. Yeah, let's see how that goes. Maybe we end up in an overflowing state. Yeah, we do. So we need to clip it as we do with our buttons here. So max text size, I really haven't found any use for it. I think it probably is a bit wasteful to calculate both the maximum possible text size and the actual text size because it will simply iterate over every character, and I don't think it's very fast or any smart to do that. We could do some optimizations in that regard. So we will use calculate text size. It simply just clamps to whatever text size we need. Let's see, we don't need the restricted text size as an output here. And we will delete this. And we will add this. It won't change anything, but it will definitely be more efficient since this function here kind of breaks whenever we have reached our maximum, and since it's using the inner rectangle of whatever window we're trying to render to, we won't be overflowing. You could restrict it to the actual button size if you wanted some exact size, but yeah, right now it doesn't matter too much for our use case here. So let's see, we will be calculating some, did I calculate it into a vec? Yeah, I do. So let's just copy this. It's basically the same anyway. And we of course need an unsigned int here. Usigned, unsigned, who cares? And then we will, oh, it needs to be I think I invalidate it usually. And then we can set the a std string text equal to our label, where we will text erase, and we will simply use the offset, which is our index of bounds. It's a weird name, but anyway, and we will use the text here. Should we pass in a, does it accept? Well, you could, yeah, it does accept a string as well. Okay, as you can see here, our text doesn't overflow now, but we do not calculate our size because it's hard-coded. So into the application. So if we change the size to the text size here, we will get something that looks better. And then if we increase the size of the list box here, not the button, but the list box. Let's see, the X is supposed to be just maybe 30 pixels wider. We suddenly have a list box here that is scrollable and that is selectable. So maybe that's a glitch. Yeah, I don't know. Maybe that's a glitch, maybe it's not. Anyway. So this means our UI is now perfectly linked up to our system, which means that we can actually do a dynamic UI initialization. Since we control this by value, we could do sections where, for instance, let's do another application tester value here, bool, the activate test activated false. Okay, so if we press this button here, we want to change activated, whoops, equals the opposite of activated. Then if activated, we want to create these buttons here. Otherwise, we will just do this. And then we can add a button here, increment. Let's do decrement. And we could even make our program crash if we wanted to. So our tester value here, no. Let's see, unsigned int tester value true. Let's set it to 7. Tester value 2. If we ever press increment, we increment this. If we press this one, we decrement this. And we of course need to add some semicolons here. Hello, man. That sounds great. Did you get good results or? Okay, let's see how this turns out. So if we press our test button, you can see we kind of open and close some menus here. Okay, I shouldn't render a lot of this text here. Let's just add like here. Okay, so if we add something there, we can increment, decrement, increment, decrement. Let's see if we can make a program crash. We could. it certainly crashed because we have no bounce checking on this value, so it just invalidated the whole int probably. Anyway. Yeah, DirectX 11 seemed to have problems with the constant buffer, vertex buffer, map on map functions. It's definitely better in DirectX 12. They made a lot of improvements. All right, I think this UI is at least useful. Let's see. It doesn't matter that, and it remembers the value, of course. So the last quality of life fix that I really want for this system here is we've actually done this. Yeah, that's nice. Definitely helps. We would want this. I'll do this probably during the weekend because it requires a rewrite. Yeah, that's pretty fast. So yeah, we want to fix the scroll bar issue where it needs a click plus release to work properly. Yeah. 1 second is pretty slow in terms of real-time rendering, but yeah, of course it seems fast in absolute terms. If you could do it in maybe 1/10 of a millisecond, then it would be real-time rendering speed. But it probably doesn't allow for such nah, and the PCI lane is probably not fast enough to support it. I really don't know what the restrictions are. Maybe with PCI 5, but no graphics card uses PCI 5 yet, so. Anyway, I think this UI here has come along pretty nicely. I'm definitely in a mindset where I can see this working out. So we can create lists of different items. There are of course ways to optimize some of this code here. Yeah, instead of calculating the exact size of the text, we could use a shortcut by using the font size and some different averages to kind of like compute how large each text should be approximately, and add some padding, and then we would have probably a faster algorithm in terms of determining the button size. Yeah. But yeah, we will also add a function to hide the UI, which will also give us back some performance, because we will add some optimization steps in regards to that. So whenever a UI is closed, we don't need to spend time trying to render it right now, as it's immediate mode an immediate mode UI. Everything does get rendered for each frame, or at least computed. I also have to look into how many allocations and deallocations are going on, because that will probably speed it up. Anyway, yeah. The problem is that most of it is serialized code, so all we can do if we end up in a situation where it takes too much CPU power is to do it multi-threaded, as I actually did a test up here. I did a future with a call to std async with a lambda, which had all the function calls. It worked fine. It just didn't give any performance benefit. Um, I don't know how you do it in DirectX 12, 11. Oh, okay. I create I have a specific shader for text, so it's probably easier to understand if I just show you the shader itself. Um, it's an instance draw call, so I use one vertex data structure per 4 vertices, which contains a compressed position, which is the position in screen space on the X and Y. And for each vertex, I manipulate them in the correct draw order by setting the UV or slash vertex index through the shader itself, and then I map it onto a texture with a series of glyphs. Yeah, so each character is basically a vertex with a position, a texture, map coordinate, and a potential color that should be used to draw the text. So in order to create a string, you create a vector of these vertices. And remember what I said, each vertex leads to actually 4 vertices because of instance drawing. I also do it as a triangle list, meaning that, let's see, let's open the renderer here. When you do it as a triangle list, you kind of like save 2 vertices on each draw call. Let's see. Okay, I can show you how I submit the data. So I use dynamic buffers on the upload heap, since I do immediate mode UI rendering. So we need to update this each frame. So I simply copy the primitives, which are just rectangles for now, and then I copy each glyph slash character that needs to be drawn into my GPU buffers. And as I've mentioned, this UI element is simply a position set in screen space, meaning only X and Y coordinates, and of course in yeah, and it's highly optimized in DirectX 12. In DirectX 11, it's really slow. Yeah, it is. It is actually the same thing. It's just me that created a wrapper, but in DirectX 12, it's much faster, much faster than DirectX 11. DirectX 11 needs to do mapping and unmapping in an entirely different way than DirectX 12 needs to. So basically, you can do a map whenever you initialize the whole object and never unmap it before you destroy the object again. And that means that the memory is always mapped. It's never filled with any garbage values. It's always initialized and clear, ready to be uploaded to, and it pertains to both constant buffers and all kinds of buffers. So yeah, that's a performance optimization that they implemented in DirectX 11.1. I don't know. Maybe not. I don't know. DirectX 12 is faster no matter what than DirectX 11, but it's up to you to implement it in a performant way. So you could say that DirectX 11 is more idiot-proof. It will approximate the most optimal way to do things, but there might be better ways. And it has its drawbacks in terms of the API being slow in different areas. So yeah, you could try migrating if you care about the FPS, but it doesn't seem like you need them. I mean, who needs more than 60 anyway? Yeah, as uh, also be mindful of DirectX 12 inherently supports multi-threading, which means that if you have a lot of CPU-sided work and a lot of GPU-sided work that that could run in parallel, it will definitely lead to way more FPS. So for large complex objects that need manipulations of their vertices on both the CPU and GPU side, yeah, DirectX 12 would definitely end up being faster. But it all relates to the amount of draw calls, how many chunks that the work can be divided into, and how much overhead there is to the actual synchronization work and so forth. But yeah, well, it's not only the draw calls, there's a lot of stuff, but I know the mapping and unmapping in DirectX 11 is actually a problem. NVIDIA wrote a long article about it, so that's a fact. It's in 11.0, it's really slow. It's better in 11.1, and it's way better in DirectX 12. And I even think DirectX 12 Ultimate is even better because they kind of like implemented a whole new type of write-friendly, read-write friendly GPU memory, or rather read-write from the CPU side into GPU side memory allocation that was way more efficient. So yeah. But anyway, that's a different topic. Well, it happens to be that I here on YouTube have created a complete beginner's tutorial on DirectX 12, so I even used the last part of the live stream to show how you could load custom models and everything with that basic. No, it doesn't, but yeah, I guess you could figure that out yourself. If you need multi-threaded work, you just need um, command queues and one command list and command allocator for each thread that needs to collect commands. But yeah, since you only are doing 4 draw calls, I suspect that most things could be handled by a single thread, both on the CPU. Or, uh, yeah, I don't think you will find it that troublesome if you're comfortable with DirectX 11. Anyway, so I was considering, yeah, it usually does. That's the way of the graphics APIs. So yeah, I think yeah, who doesn't? Who doesn't? I don't know how many tutorials I've done on DirectX 12, but luckily now I understand what's going on. Mostly, at least. I can usually debug whatever I stumble upon. So I think that's a good sign that most of this stuff does make some kind of sense. Anyway, I was considering ending the stream here. Before I do that, yeah, oh, yeah, I need to go grab something to eat and probably wind down a bit. Uh, yeah, I'm there. I think I need to go do some other stuff. I just well, I guess I also think that the missus want to go to bed fairly early, so yeah, I wouldn't be able to stream for a substantial amount of time anyway. But yeah, I think all this. Well, remember that I'm not a professional programmer. That might be the explanation. No, I'm just kidding. Thank you very much. So the plan is for the future episode here on the stream is to not only fix the scroll bar issue, but also implement a text box with editing. And whenever we have added editing with updating our values, that means that we now would have a fully functional UI that can be used to edit objects in our level editor. And that means that whenever this one gets done, I can start creating a level editor and actually creating some levels. And that means that we can move on from all this UI stuff. But I do think that the new UI system is way easier to handle, and also it's easily multi-threadable. So if I wind up in a situation where I want to use my CPU for something else, I can just spawn all of this in a different thread and do some physics or something on the primary thread. So that's pretty awesome. That is pretty awesome. Yeah, I've been spending too long on this level editor project here. I want to do some more interesting stuff, but I think working usable UI is also a pretty big part of all of this. So yeah, I guess I've just had to suck it up. But how are you guys projects going? I heard a lot from Fanbjerg, uh, but how about you other guys? Is everything going according to plan, or? You quit your project. Why is that? Not the Vulkan? Oh, that's great. So you're sticking with Vulkan so far, or? Yeah. Is your plan to redo what you did in OpenGL for the Vulkan engine? Yeah. Did it work out as you hoped, or rather, as we discussed? Why not use ImGUI? So ImGUI is not efficient, or did you find something else that you want to use instead, or? They aren't efficient? It should be fairly easy. You just change the implementation calls to Vulkan instead of OpenGL. Otherwise, it should basically be the same. Let's do this as first priority. Well, GUI does that for you. I'm pretty sure. You simply have to do maybe 2 function calls, and the GUI API just does everything for you. At least that's how it works for every other graphics API I've seen. Well, I guess there's no deadline, so you can do whatever you want. All right. Well, I think I'll round off the stream. It was nice hanging out and hearing from you guys. Yeah, so the plan is to implement a text box, which I can do some editing in, so that we can start editing our objects. Then I'll fix the scroll bar, and whenever I get to it, I'll do the quality of life improvements. I might do them in between episodes. I might do them on stream. I might do them in between stuff, because they are just some basic improvements. Not really a lot of interesting stuff going on. It's just some boilerplate stuff. So yeah, and then we will add some then a level editor. Um, and to implement the level editor, we need object picking. Click on an object in view space to select it. We need some sort of gizmo thingy that allows you to drag objects in 3D space. We also need a level container that can load and write to file. It's fairly easy. It's fairly easy. It's just a basic math. I mean, you simply translate from screen space into the view frustum space, and cast array, and do intersection tests on simple bounding volumes. And since I'm already doing the physics stuff, I have intersection tests already inside the system, and you just simply cast the array and see whatever seems to be the closest object to the camera. And there you have it. If your scene is divided into bounding hierarchies in terms of 3D space, you can even do optimizations on it. Yeah, sure. I'll try to show as much as possible, but a lot of it will probably involve math because we need to do inverse matrices to translate translate the coordinate system back into view frustum space from screen space. So it'll probably be a lot of math. A lot of math. A switch in the renderer to allow static baking of objects. And then I think since I've noticed that the poll on the channel has suggested that we should do some rendering stuff. I think the next part of the roadmap is shadow mapping. Bloom effects or something like special effects, and yeah, we'll do shadow mapping, and then yeah, I guess we can do that down the line. Then we do some shadow mapping and then some game mechanics because we need to make an actual prototype here. Um, so we need to make actually along the path here, we will start a design document which will hold our world information. How big are things going to be? Yeah, sound, well, that's way down the line. We need some interesting things going on before I add sound. Need to do some shooting stuff. Prototyping. So this is the rough outline for the next part of this project. Yeah, we've actually already have the some parts of the implementation for it, since it's usually just a raycast that needs to be checked if it's blocked. But yeah, we're definitely close to doing some of that. But yeah, maybe some AI programming or something needs to be not in terms of artificial intelligence, but rather some enemies or something. We need to develop some fun mechanics. Fun. But yeah, I think that is it. It was nice. But yeah, it was nice hanging out with you guys and updating you on how far the UI have come in these past few days, where I've not had the time to stream any stream here, but yeah. Yeah. As always, it's been my pleasure to interact with everyone who dropped by the stream. Good luck with your projects, and hopefully I'll be seeing you around here on the channel. Stay healthy, take care of yourselves. I'll see you around. Bye bye.